Welcome students to the second part of the lecture number 4 of computer system architecture. Students, let's start our discussion with the conversion of a binary number to its octal and hexadecimal equivalent. Students, to convert a binary number to an octal number, firstly we will write the binary number in the groups of size 3, and after that we will find the decimal equivalent of each group, and at the end we will combine the decimal numbers of each group to obtain the final number. We can understood this with the help of example. Here in example number 1, we want to find the octal equivalent of the binary number 110111011. So firstly we will make the groups of size 3 from the right hand side. So the first group will be 110, the second group will be 111, and the third group will be 011. Now in the second step we will find the decimal equivalent of each group. For the first group the decimal equivalent is 3. For the second group the decimal equivalent is 7, and for the third group the decimal equivalent is 6. After that we will combine these numbers. So the octal equivalent of this binary number is 673. Students, you can check this second example also. In this example the groups are 100, 010, 100, 011, and 1. Students, you can see that the last digit is the last group is not complete. So in this case you will add two zeros to complete this group, and after that you will find the decimal equivalent of each group. So the decimal equivalent of first group is 1, the decimal equivalent of second group is 2, the decimal equivalent of third group is 1, the decimal equivalent of fourth group is 6, and the decimal equivalent of the fifth group is 1. And in this way the final number is 16121. Students, let's now understand the binary to hexadecimal conversion. Students, it is similar to the binary to octal conversion. The only difference is that in this case we will make groups of size 4. Let's understand this conversion with the help of examples. In example number 1, the binary number is 110101011. So in this case we will firstly make groups of size 4. So the first group will be 1101, the second group will be 0101, and the third group will be 1. Now here we can see that in the third group the elements are not complete, so we will add zeros in this case to complete this group. Now we will find the decimal equivalent for each group, and after that we will change the decimal value to its hexadecimal value. For example, the decimal equivalent of first group 1101 is 11, and this value is represented by B in hexadecimal. Similarly, the decimal equivalent of the second group 0101 is 10, and it is represented by A in hexadecimal. Similarly, in the third group the decimal equivalent is 1, so the final value in hexadecimal is 1 AB. Students, in the second example the groups are 1000, 0101, 0001, and 11. In the fourth group we will add two zeros to complete this group. Now we will find the decimal equivalent for each group, and after that we will convert that decimal equivalent to its hexadecimal equivalent. For example, in the group 1 the decimal equivalent is 1, and for group 2 the decimal equivalent is 10 and its hexadecimal equivalent is A. For the third group the value of the decimal equivalent is 8, and for the fourth group the value of the decimal equivalent is 3. So finally the final value of the hexadecimal equivalent is 38A1. Students, let's now understand the conversion of octal and hexadecimal numbers to binary numbers. Students, in octal to binary conversion, firstly we will write the octal number, and after that we will write the binary equivalent of each digit of the octal number. Now, thing that you should take care of is that the number of digits in the binary equivalent of decimal number should be 3. For example, the binary of 3 will be 0, 1, 1. So in this example, the value of the binary equivalent of 343 will be 110 001 110. Students, you can check this second example also. In this case, the number is 21413, and the binary equivalent of this number is, for 3 the binary equivalent is 110, for 1 it is 100, for 4 it is 001, for 1 it is 100, for 2 it is 011. So the binary equivalent of the octal number 21413 is 110 100 00110010. Students, let's now understand the conversion of a hexadecimal number to a binary number. Students, in this case, firstly we will find the decimal equivalent of the hexadecimal number, and after that we will change the decimal number into binary. For example, in example number 1, the number is FE2B. We know that the decimal equivalent of B is 11, and the decimal equivalent of E is 14, and the decimal equivalent of F is 15. And after that we will find the binary of each of these. So the binary of 11 is 1101, and the binary of 2 is 0100, and the binary of 14 is 0111, and the binary of 15 is 1111. So the final result is 1101010001111111. Students, you can check the second example also. In this case, the number is AF86C. Students, the decimal equivalent of C is 12, and the decimal equivalent of F is 15, and the decimal equivalent of A is 10. Students, now we will change this into binary, and we know that the binary of 12 is 1100, the binary of 6 is 0110, and the binary of 8 is 1000, and the binary of 15 is 1111, and the binary of A is 1010. Students, finally we will combine all these values to find our final result. Students, let's now discuss octal to hexadecimal conversion. Students, octal to hexadecimal conversion is a two-step process. In the first step, we will change octal into binary. Students, in step number 2, we change the binary into its hexadecimal equivalent. Students, in example number 1, we want to convert the octal number 343 into its hexadecimal equivalent. So in the step 1, we will find the binary of the octal number 343, and we know that the binary of 3 is 110, and binary of 4 is 001, and the binary of 3 is 110. Now we will combine these numbers together. Now in step number 2, we will change this binary number into its hexadecimal equivalent. For this, we will divide the binary number into groups of size 4. For example, in our case, the groups will be 1100, 0111, and 0. Now we will find the hexadecimal equivalent for each group. For first group it is 3. For second group, we know that the decimal of 1110 is 14, and which is equivalent to E, and so the final value we get is E3. Students, you can check the second example also. In this case, we want to in this case the octal number is 7675201. Firstly, we will change this into binary, and the binary will be 100 000 101 101 111 and in step 2 we will divide this into groups of size 4, and we will get 1000 0001 0101 1110 1111 and 1. Finally, we will find the hexadecimal equivalent of each group. For group 1 it is 1, for group 2 it is 8, for group 3 it is 10, which is equivalent to A, for group 4 it is 7, for group 5 it is 15, which is equivalent to F in hexadecimal, and for group 6 it is 1. So the final value is 1F7A81. Students, let's now discuss the conversion of hexadecimal number into octal number. Students, this is similar to the octal to hexadecimal conversion, but in this case, firstly we'll change the hexadecimal number into binary number, and after that we will change the binary number into its octal equivalent. For example, in example number 1, the number we have is E3, and in step number 1 we will change this into binary. The binary of 3 is 1100 and the binary of E is 0111. In step number 2 we will combine these, and after that we will divide these into groups of size 3, and so we will get 110 001 and 11, and after that we will find the octal equivalent of these binary numbers, and so for the first group it will be 3, for the second group it will be 4, and for the third group it will be 3. So the octal equivalent of E3 is 343. Students, you can check the second example also. In this case, the number we have is 1F7A81, and firstly we will change this number into binary, and uh, we know that the binary of 1 is 0001, the binary of 8 is 1000, and the binary of A is 1010, the binary of 7 is 0111, the binary of F is 1111, and the binary of 1 is 0001. In step number 2 we will combine these, and after that we will divide these into groups of size 3, and after that we will find the octal equivalent for each group. So for group number 1 the octal equivalent is 1, for group number 2 the octal equivalent is 0, for group number 3 the octal equivalent is 2, for group number 4 the octal equivalent is 5, for group number 5 the octal equivalent is 7, for group number 6 the octal equivalent is 6, and for group number 7 the octal equivalent is 7. So the final value in octal is 7675201. Students, this was the end of second part of lecture number 4. Thank you for attending this lecture. See you in the next lecture.